say that electrons are moving in a material, in a substance, and then they give rise to current. So I write here, moving electrons produce current. Okay, moving electrons produce current. So my question is, how much of current? How much current will they produce? It depends on how many charges are moving in a given time. How many charges are moving in a given time, that much of current will be produced. Okay. So in physics, we need to put everything in the form of a formula. We should have a formula to calculate every quantity that we talk about. So current is also a physical quantity, right? We have just understood that current is a physical quantity, and current is denoted by the letter capital I or small I. Current is denoted by capital I or small I. So how to calculate current? So current is equal to how much? How to calculate? Now remember, charge is represented by Q. Charge is represented by Q. And current is represented by I or capital I. I told you just now how many charges will flow in a given time, that much of current will be generated. So current depends on charge and what? Current depends on charge and time.
Number of how much charge it produces.
Very good. How much charge is moving, that much of current is produced. Now just like, we exercise to lose calories, right? How much exercise you do, how much more exercise you do, that many calories you lose. So similarly, how much of current is produced depends on how much charge is moving, how many electrons are moving in a given time. If I want to calculate the speed at which you are running, I want the distance covered by you and the time taken to cover that distance, right? So similarly, to measure current, I need two physical quantities, charge and time. So charge is represented by letter Q, current is represented by capital I or small I, and the expression for current, I is equal to charge by time. Shall I proceed? So this is the definition of current. I am very much hopeful that you have understood the reason of current, and then we have known the definition, its meaning, and then we have a formula also to calculate how much of current is generated, how much of current is produced, and then what is that missing here? My dear students, all the time you can't write a full expression. So we have symbols to represent. Charge is represented by Q and time is represented by T. So current is equal to charge by time. Okay. And now the very important thing we need to know about current is its unit. Because without unit, there is no sense to current. In fact, there is no meaning at all to any physical quantity without a unit. Like just without a name, how we become, identityless. We will not have any identification without a name. So does a physical quantity. It should have a unit for its identification. And the unit of current is ampere. What?
Ampere.
Ampere. Very good. It is a name of a scientist who have done a lot of research and have
Ma'am,
contributed
these
a
are
lot
the
to this.
units of current, right?
Exactly, Nana. This is the unit of current, ampere, and this is the standard unit. Hope you know what is an SI unit. This is a standard unit which is used universally and officially.
Ma'am, like
The
for
unit of
length we use meters as.
very good. Exactly, Nana. Just like how you use meters for length and Kelvin for temperature, second for time and kg for mass, we use this ampere as a standard unit for current. And here is a secret. If at all you have elder brothers or sisters at home, go and ask them what is the serious unit of current, and they will not be telling you any answer because they don't know. And here I am sharing that very important and very less known unit of current, which is bio. I appreciate that, but let me tell you that we are getting current into our home from a power station, right? On a large scale, current is generated in power stations by different processes, and then that is being directed into our home, and then we are using it for several purposes at home. So power station is one of the source from where we are getting the current. A real torchlight will be of this shape, in which you have to instill batteries in it, and then there will be a bulb inside which will be glowing when this is switched on, right? You will take a torchlight into your room and will be switching it on, and immediately you will be seeing a flash of light at home. And how is this light glowing? Your voice clearly.
Ma'am, can I tell the reason behind it? Why is it glowing?
Yeah, why is the bulb glowing when it is switched on?
Ma'am, when it is switched on, actually there is a circuit formed. When we switches on, that time the wire connected all together and it forms a circuit. And when we turn it off, that time the circuit breaks and the light offs.
Very good. I have explained the entire thing that is going on when it is switched on. But the basic behind this happening is the cell. If I take out the cell, I switch on the torchlight, will the bulb glow? No, right? So the bulb is glowing because of this cell. What is this called? What is this called? A cell. A cell is the smallest unit for producing electricity. Power stations are the biggest unit where electricity is generated. Nuclear plants are the biggest units where power is generated. And the smallest unit you can find that produces an electricity is cell. The smallest unit which produces electricity is a cell. Are you all able to see this?
Yeah, ma'am, we are able to see. You are catching a battery, right?
Actually, we call it as a battery, but technically this is a cell. A single unit, this one is called a cell. So this is what actually I am trying to put here. This is a cell. Generally, we call it as a battery in our daily, in our regular language, we call it as battery, but this is a cell. Okay. So this produces electricity. That is the torchlight is being turned on. That is the watches are running. That is the radios are running. Isn't it? So the smallest, the very little unit that produces current is a cell, or I can call it as electric cell. Because it is producing electricity, I can call it as electrical cell.